Okay, hello. After taking some lectures, I think you have some ideas on how to get familiar with the concept of the biodiesel. So in this module, we try to demonstrate some experiment about how to do biodiesel by using oil, right? So the process involved triesterification. I think you may know the word triesterification. So that no doubt that I think you have some ideas on it. So in this demonstration, I try to do the experiment and you need to take a record about the experiment so that please pay attention what the description and also the result solution. And you need to take a look for the result solution so that you can get familiar with the product of biodiesel. Okay, firstly, we try to prepare apparatus and also chemicals for experiment. Firstly, this is alcohol lamp. Alcohol lamp is we try to give a heat to the oil. This is the oil, which is plant oil, right? Plant oil. So that this is the component of biodiesel, right? And second is methanol. This is methanol. Methanol is a kind of the solvent, organic solvent, used ordinarily in the laboratory and in commercial purpose. But now we are now doing experiment. Triesterification. This is the major component for this. And the third component is this one, this crystal, right? The crystal, we can call this sodium hydroxide. Sodium hydroxide, the purpose of the sodium hydroxide is a catalyst of the experiment. If we cannot provide catalyst for the experiment, it will very slow. Okay, for the reaction is very slow. Maybe the time for experiment maybe more than half day. But if we provide catalyst, okay, for the experiment, it try to speed up the reaction. And also the purpose of adding sodium hydroxide, we try to lowering an activation energy of experiment so that they can achieve the plateau. I think you may know the graph of the activation energy. So when there is getting high and the plateau and decrease generally, and then the plateau is a activation energy, right? I think you may know the concept for this, but so I will not elaborate for the activation energy because this is not the major learning objective of this module. So, okay, so we try to demonstrate such experiment to you now, okay? So we have the container here, right? Okay, the container here. And also we try to heat up oil first, right? Heat up, the temperature is around 50. So we try to use thermometer. Okay, we try to use thermometer to measure how the temperature of the oil, right? Okay. So we try to measure the temperature of oil. The room temperature is 24 here. So this is 24. So our aim, we try to heat up the oil into around 50 to 55 degrees Celsius, right? Okay, so we try to switch on the fire. Okay. Okay, the fire is now on. So we try to heat up oil until to 50 to 55. So we need to pay time to, we need to pay attention and also time the time whatever it achieve 50 degrees Celsius. Okay. When we try to heat up the solution, please pay attention. We need to stir the solution. Actually, we have stirrer to stir the oil, but I'm now using thermometer. It's not a good common practice. Okay, please don't try to please don't try to learn this because I haven't had any stirrer. So that okay, what the thing is that we try to use it as a stirrer. So it's now the temperature is raising. So we will finish heating around 50, as I mentioned, 50 to 55 degrees Celsius. Why we try to keep to heat the oil? Because at least we have provide energy for the reaction of the triacidification. Without heating, I think the solution and also the reaction that cannot progress, right? So in the real life situation, we cannot perform triacidification at room temperature because we haven't have enough heat energy for the reaction. Okay, so you may find that the temperature is around 55 to 60 around it, right? Okay, so we can stop heating. Okay, what the thing is that we try to transfer oil into the container. Okay, so and also we try to add the catalyst. Okay, as I mentioned, this is sodium hydroxide. We need to add a catalyst, and the amount it doesn't matter. The amount of catalyst is approximately the same. It is not important, and also not the critical point to affect the experiment. So that I try to add the catalyst here. Okay, so we try to add methanol. I measured it before, right? The volume is 10 ml of methanol. Okay. Why we try to provide such container? Because such container, we try to shake it. Okay, we try to shake it. So you may find there is a milky substances formed, right? We will quickly to stir the solution. Okay, so you may find that the bottle expanded. Okay, the bottle expanded. So we need to release the gas. Okay, and then we try to continue to shake it. And I think we need to shake it around 50 minutes. Right? We need to shake it around 50 minutes. Okay, during the time, you need to observe. You need to observe the changes of the layer. Release the gas. Okay, and then we go back to this. Shake it, right? Shake it rigorously, actually. And some experts try to use water to remove impurities in the biodiesel, but this is not a good practice because oil and water, they cannot soluble to each other. They are not miscible to each other. So that it is not advisable to use water to remove the contaminant. Instead of, we try to use another method to remove the contaminant. instead of water, although water is inexpensive and convenient, right? Okay, we try to use solvent elaboration or extraction method to remove the contaminant instead of using water. So if water present in the biodiesel product, I think your car will be locking, right? That means they will combust the diesel very rough. Okay, so you may find very you find not comfortable when you take the vehicle, right? Okay, so we try to release the gas. Okay, and then repeat the procedure, right? Repeat the procedure. And the time is going on, right? Because we need to shake 50 minutes. It is impossible for me to shake it. Okay, you try to take a look to me and 50 minutes and you get just shaking. Oh, you may fall asleep, right? You know. Okay, so as the time goes on, I prepare the final product to all of you. This is final product, right? You may find this is final product. Okay, so you may find there is a layer, right? Is it? There is a right layer here, right layer. There is a transparent, right? Okay, so for the upper layer is biodiesel, right? Lower layer is a fat residue. Because when we try to perform triesterification, it will further to have another reaction, which is called solidification. Solidification, that means we try to produce soup, right? Okay, soup. That means, okay, you use this soup for bathing, right? Okay, so at the same time, it will produce soup. So in biodiesel, the critical point is that we try to remove soup in the biodiesel. It's very difficult, right? Okay, if we try to provide more contaminant such as water, it will be further increase our or further lowering the performance of the biodiesel. So that it is better to eliminate or minimize the contaminant such as water. And also we try to use the method we try to separate biodiesel from the mixture, right? This is the thing we need to do for the biodiesel that can be used in commercial, right? Or in our real life, right? So that okay, I try to repeat the experimental procedure. Okay, the first thing we try to heat up the oil at around 55 to 60 degrees Celsius, and then we try to add the catalyst, and the amount of catalyst is approximate amount of it, and we try to add 10 ml of the methanol, right? Methanol into the mixture and shake it rigorously. And during the time, we need to release the gas, right, within the container. And then after 30 minutes, we try to stand the solution on the desk and stay for 1 light or 2 lights, okay? So that we make sure all the soup content and molecule find it at the bottom, and also the biodiesel find it at the top of the mixture. And in commercial basis, we try to separate these 2 layers by using physical method or chemical method is okay. Such as for physical method, we try to use centrifugation. That means we try to centrifuge the mixture so that biodiesel that can be separate from the mixture. And then chemically, we try to use some chemicals. We try to extract the desired product from the mixture, and then we try to further purify, and we try to purify the product. Okay, how to make sure the product that can be used in commercial, right? As I mentioned before in the lecture notes, we try to use gas chromatography, mass spectrometry method to test whatever there is a peat present in the mixture. The peat represent your target biodiesel was found in the product, so that this is the way for you to test the purity and also how to control the quality of biodiesel used in commercial or in your own use, okay, for the product. So that this is the first part of the experiment of tri-esterification, and this is the basic concept for the reaction. And this reaction cannot represent the true situation, because in true situation we have many difficulties to overcome it, such as the component of the ingredients and also the purity for the gradients, and also the amount of methanol used may be changed from time to time due to the reaction. The reaction may be varied, okay, in different situations. Okay, so this is in lab scale we have a demonstration on this, but in the commercial scale we need to control the whole process carefully so that we assure the quality that can be meet the standard, and then that can be used by the car owner and also used in commercial party. Okay, so that's the end for the first part of the experiment.